In this video, I'm going to present a Vocoder application which is designed in MATLAB. Before going forward, I'm going to give a brief overview of Vocoder processing. The block diagram shown in this figure shows a Vocoder processing signal flow. The input signal is first synthesized using a set of bandpass filters. For each frequency band, we calculate the envelope. We add the noise and use the same carrier filters as synthesis filters, and then sum up the signal to get a vocoded signal. Coming back to the vocoder application, here first thing we do here is load an audio file. We load a vowel consonant vowel file, here in this case asa. Then we choose set of synthesis filter banks. We have options here. I choose the ACE default filter bank. I have selected pre-emphasis and normalization, and then I have chosen the vocoder method as noise band. For the carrier filter banks, I have used the same filter banks as of the synthesis one. In this case ACE default filter bank. I update here and I get a vocoded signal. This section shows the original ones, and this section here shows the vocoded signal. Now when I play the vocoded signal here, this is done for the 22 channels. We can also change the vocoder method. If I change this to the sine wave vocoder and update it, and I see 22 channels of sine wave vocoder. This is how the vocoded signal sounds like. In this application, I have the option to select different synthesis and carrier filter banks. In this example, I'm going to use filter banks which are derived from image boundaries. First thing I'm going to do is to select electrode distance curves data. I would select a subject, let's say S1. Here are the curves for S1, and according to this I'll use the filter banks derived from their image boundaries. I've used the center frequencies as pointed by the filter boundaries in the curves, and then use the noise band again and update it. As you see, now the spectrum spans to the entire range as specified in the filter curves, as shown here. Now if you listen to this vocoded signal, it sounds something like this as compared to the original. Now if I change the synthesis filters to resemble the same, we can see the difference much more clearer. Now let's change the filter banks to original default filter banks for synthesis ones and select the different subjects. Let's say S8. We have the curve data here, and we update this, and here's the sound. Select a different subject again, and so on. Another feature in this application is to use filter banks which are derived from image curves directly. So the shape of the filter bank resembles the distance versus frequency curves here. This is done in frequency domain. As you can see, the boundaries, the filter range and the filter shape is different. For example, in this case, there's a lot of non-linearity in it. So if we process with such filter bank, The spectrum of the resulting signal looks something like this, and this is how it sounds. This processing takes relatively a longer time to process. Now let's change the filter banks of the synthesis filters to the image curves as well, and then update. The waveforms of the recorded signal looks something like this, as well as the spectrum. If we play it, it's much clearer when it's in matte condition. Returning back to the default settings, let's select a different audio file. In this case, I'm going to select an IEEE sentence.
Blue the sheet to the dark blue background.
Using the ACE default filter banks, the recorded signal sounds something like this.
Blue the sheet to the dark blue background.
And using the image boundaries, for example, if I choose subject as 3, the signal sounds something like this. And now when it's in match condition, now the whole idea behind this vocoder application is that synthesis filter banks resemble the processing which is being done in CI processes, while the carrier filter banks resemble the frequency place mechanism within the cochlea. So if we design synthesis filter banks which are a balance between covering the audio spectrum and frequency place within the cochlea, we can increase or we can improve the speech quality perception within cochlear implant users.